That's why. Okay. That explains why it wasn't answered. Is it Reed? Okay. Elise, right? No? Yeah,
No, Devere, Caitlin Devere.
that's right. Sometimes my brain just sticks with where people sit. I think she was sitting there earlier today. Come on in. Should we, I think we have everything we need. Perfect. Do you mind writing your name and contact information on the board for the students? Thanks. Let's see. Here we have case number by Reed, right? Yep, okay. Is it Tristan? Let's see. Morgan? Yep. Mathis?
Yeah.
Okay. Thompson? Okay. Covington Griggs? No. What's your last name? Thank you. Okay. And then Elkins, yeah. I think I've got everybody so far. Still have 2 minutes. Here, is here, is here. Not here, is here, is here. Not here. Is here. Not going to be here, is here. Is here, is here. Is not here. So there's no release yet, right? Still have time. Good. Morning. Covington Griggs? All right. Here. Here. All right. Well, we still got 1 minute. And we're only missing one person. Wait now. Let's see. be here. Missing that person. Not gonna be here. 2 people. Might be missing 2 people. We'll see. While we're waiting, I will say today's lab might be a little bit, oh, good, it's 10. It might be a little bit longer than the average lab because it's the first lab. So not only do we have to do the actual experiment, but I've got to introduce you to stuff that you'll need to know for the rest of the semester. So I'll only introduce it once. We've got to go over the lab syllabus, which I'm going to do this one time. So be prepared for that. That's why I was saying earlier today that we might be here till 11:50. You should always plan for that just in case. Since it's 10 o'clock, I will officially get started and do attendance since I'm recording this. Again, I will try to record these. That way, when you're going back to work on your lab, if you need, like, I don't remember what he said, you can watch the video, hopefully. All right, so Bagheera's not here. Case Bolt's here. Tristan's here. Covington Griggs is here. Gately is here. Dow is here. Hughes? Yes, Hughes is not here. Carla's here. Mankins is not here. Colton's here. Rains is here. Reed is here. Elise, no Elise, right? First name Elise. Just double checking, not here. Thompson's here. Woodrow's not here. Dewey's here. Elkins is here. That's everybody. Did I miss anybody? All right, it's 10:01. Let's get started. So like I said, this is gonna be a little bit longer. Before we jump into lab 1, I want to show you something very quickly. Thompson's here. Oh yeah, so one more thing to say too. Remember how I kept saying I'm gonna lock the doors at 10 o'clock? That was just a scare tactic for the first lab. After this, I will lock the doors at 10 o'clock. Just like I said, if you didn't do the pre-lab before Friday, you couldn't come to lab, but then I extended it. But starting from now on, if you don't do the pre-lab by Friday, you can't come to lab. I need time to grade it and make sure that you're ready to come to lab. Anyway, we got Thompson, hold on, what's it say? Where was it? Come on. Just Hughes, right? Hughes? Okay. Hughes is here. All right. Anyway, really quickly, let me show you this. So to remind you, like I was saying, pre-labs are always due by Friday. I need time to grade it. So really quickly, I just want to show you something for next week's lab. So the pre-lab that's due today, you go to my online, like you can see scrolling. I know it's a little bit hard to see because of the lighting, but you go to module 2. It's kind of in the wrong spot, but that's okay. This is still the next lab, right? Lab 2. So if you go here, click on this just like you did for this lab. When you click on this, obviously it's going to bring you just like it did to the master document, like same way it was this week. You go to File, make yourself a copy, so on and so forth. You're going to do the lab. And the only reason I'm going through this, some of you are like, yeah, we know, we already did this. Some of you didn't do it properly. So I'm showing you once again how to do it. You go through, read this, fill it out. But I do want to point this out. This is different from this week than it was last week. This time you have 2 short videos you need to watch. So make sure you watch this video and answer these questions while you watch it. And then you watch this video and answer these questions while you watch it. They're short, like 12 minutes apiece.
And this is due this Friday.
Yep, pre-labs are all due on this Friday. So make sure you do those questions before you do the rest of the pre-lab. Then it's just like you did this week. You read the introduction. There we go. Then you answer the questions, right? Once you're done answering the questions, again, you go to File. Because this is your copy already, you download. I'm sorry. I'm so glad I caught myself. Since this is the pre-lab, the way you share a pre-lab with me, you have your document, and you go up here to the top right. Yes, I'm still here. Excuse me. Anyway, you go to the top right and just share it with me. Does that make sense? Most of you got it, and I know it's a lot to learn, but so that's how you share pre-labs with me. You share the document with me. Then when you're done, like you're going to do today, once you've done the lab, not just the pre-lab, the entire lab, then you go to File, download it as a PDF, and then you upload it here to WBSU Online. So any questions about how the general process of pre-labs and labs work? All right. And then that means we are now about to officially get started with Lab 1. But before I do, you guys have already met me. I'm Vasilios T. Velos. All my information's in the syllabus. But would you like to introduce yourself? This is our TA. So he and I are going to run these labs together. He does a lot of the logistics. Sometimes he's going to do the pre-lab lectures. He'll be here to help. Sometimes it might be just me, and only him. Maybe sometimes vice versa. If you have any problems with me, I wish you would tell me. But if you don't feel comfortable telling me, maybe you can tell him. And then he can come and tell me, like, I'm not saying who, but this student thinks you need to wear more deodorant, or whatever it may be, right? So you go on and introduce yourself.
Hi everyone, my name is Ritvik and that's my contact information, and I'll be doing TA for this semester. And yeah, if you guys feel any discomfort regarding lectures or any other things, please do contact me. You will always find me on the 3rd floor on the Hamlin, particularly in 306. And yeah, that's pretty much it.
All right. You guys will get to know each other throughout the semester. All right. So let's jump into it. You guys have already read a lot of this. Obviously, you did the pre-lab. Otherwise, you wouldn't be here. So forgive me if I go through it kind of quickly because time is valuable and I don't want to waste a lot of your time. But if I'm going too fast, slow me down and say, hey, could you clarify something right there? All right. So let's go through this. You've already read the objectives. We talked about the objectives all throughout the even lecture. I talked about it. So let's talk about the syllabus. You already know the time and location. It's 10 o'clock in this room every Wednesday. I'll remind you because a couple people did come in late. After today, I will lock the door. You cannot be 1 minute late. It's usually a team effort. And if you're late, then you're going to mess up everybody else. Also, you'll just be catching up if you're lost. I said, you'll hear me say this a lot throughout the lab section. If you're just so focused on doing this direction and that direction, and you don't get the big picture, you're not gaining anything from this. You might even get a good grade just because you just step 1, step 2, write this down, calculate this, I might get a good grade. But you're not really getting anything. So it's one of those few times I'm very strict with being on time. So make sure you're on time. Pre-labs, we already talked about it. They're always due on Friday. Make sure you do it. Let me know if you need help. I would suggest at least looking at the pre-labs early. That way, if you have any questions, you're like, oh my goodness, I need his help. Because if you're working on it Friday night, and I'm having dinner with my family on Friday night, and you're trying to call me, I'm not going to answer it. So, you want to look at it early. So if you need help throughout the week, I can help you. Lab worksheets, we've already talked about it, right? You're going to make yourself a copy, do the pre-lab, share it via Google Docs. That's how you turn in the pre-lab, turn it into lab, download it as a PDF, upload it. Lab materials, we'll give you everything you need. If you need anything extra, we will let you know. I would always recommend bringing a computer or a tablet because, again, even though you're doing these experiments physically, your data collection will be digitally. Of course, you could write notes and write it on paper and then put it in later. Behavior and attendance, we already talked about that. You need to be here. Yeah, I guess I didn't say that today, but just again, to remind you, if you're not here, you can't get credit for the lab. This week's a little bit different because it's week 1, so I made some exceptions. Those of your classmates who are not here, they'll have to do 2 labs to make up for this 1 lab. So they still have to do this lab because they're going to get the data, and then they have to do an entirely different lab. So make sure you're here later as the semester goes on. You may be able to make up some of the points, but not all the points. Make sure you're here. Obviously, if it's excused, let me know beforehand, and we'll work around it, because I know there's one person who won't be able to be here for a couple weeks. Late work, again, officially, it will not be accepted. Unofficially, I'm saying if you missed the deadline, go ahead and turn it in. Right? Go ahead and turn it in, and I'll try to grade it. Speaking of which, if you find yourself, because I did this a lot as a student, like, oh my God, I have this due and this due. Which one do I do first? Prioritize your pre-labs. So technically, as I'm going to mention here in a second, today's lab is due 2 days before you leave. You're going to upload it, but that's past due on Friday. So you'll upload it today, and then you might not have it complete. In which case, you'll miss some points technically, but then you'll have until Friday to fix it. Does that make sense? Okay. Anyway, so then on Friday, if you find yourself like, oh man, I need to start to fix this lab that I just did, but I also have next week's pre-lab. Prioritize next week's pre-lab, and I want to make sure you're prepared for next week's lab. That makes sense? All right. Lab report, we'll talk about that when we get there. You're going to have 1 lab report. We're doing a photosynthesis respiration lab. It's a big one only because it's a lab report. So we'll come in the week before we do that lab. We will have the pre-lab lecture like I'm doing right now. And I'm going to tell you how to do a lab report. So the whole week prior to doing that experiment is nothing but a pre-lab lecture and teaching you how to write a pre-lab. So you'll be very prepared for it when the time comes. For now, you don't need to worry about it. If you want to for independent work, you could write lab reports on any of the experiments we do this semester. Plus, it would be good practice to help you get ready for the lab report. So if you want to do that, let me know, because you can't just say, hey, go write a pre-lab. A lot of you probably don't know how to write, go write a lab report. A lot of you probably don't know how to do that. Or more probably, you don't know how to do it the way I would want you to do it. Any questions about the lab report for now? All right, point breakdown. We already talked about this when we first talked about the syllabus last week, but we'll talk about it again very quickly. The entire course is worth 1,000 points, right? So lab is worth 300 points. That's 3 letter grades. So it's important. Again, like I already mentioned, you will do a lab report later this semester. That's worth 20 points, which is the same as a regular lab, because a regular lab includes 15 points for the lab itself and 5 points for the pre-lab. So you guys have already done the pre-lab. You got your 5 points or something close to it if you didn't get full credit. And then today, the work you're going to do will give you the other 15 points. Make sense? One person got extra credit on the pre-lab, and that might spill over into their lab. So, for example, again, pre-lab is worth 5 points. I think they've got 8 points or something like that. I don't remember what it was. But now, if they don't get full credit for today's lab, then the extra credit that they got for the pre-lab will spill over. But I won't talk much about that. We'll cross that bridge when we get there. Any questions about how much each lab is worth? One other thing, I'll reiterate this later. The last week of the semester is a free lab, so you don't necessarily need to come in. We're not going to do a new experiment. I'm going to ask you to pick your worst lab and redo it, right? So that way you can fix your grade. And we'll cross that bridge when we get there. There's other options that you'll have for your free lab. The point is, I'm going to try to make things easier for you on the last week of class while you prepare for finals and stuff like that. And again, lab report we'll talk about later. Lab safety, this is important. A little bit less important for this class because we don't really do that much dangerous stuff. But let's look at it very quickly. I want to definitely, and it's being recorded, so I want to say I went through every one of these for legal reasons. The first rule, and this is my favorite one, is think safety first. So after we go through the rest of these rules, just because it's not on the list doesn't mean you can do it. For example, nowhere on this list does it say don't cook meth in the back of the classroom. It's not on this list. But number 1 says think safety first. Cooking meth back there would be unsafe, so it falls under that category. All right, no food or drink. I am going to have to enforce this. Yeah. So this is so weird. It almost seems hypocritical, but I just don't want to get in trouble with my superiors. When we're in here for lecture, I don't care if you drink or eat. But technically, when we're in here for lab, we have this little ledge out here. You can leave your drinks out there. Speaking of being hypocritical, I'm going to drink out there. And it's, like I said, it's almost a formality because the reason you're not supposed to have food or drinks in the lab is because even though we're not working with dangerous stuff, in theory, someone else could work with dangerous stuff. So you might have your drink. Somebody may have been working with some kind of nasty bacteria on that table, and you just put your hand down there not thinking of it. Then you grab your drink, take a drink, and now you're infected with a nasty bacteria. Of course, that's only technically because technically you run the same risk when we do lecture. It's not like this room is magically clean just because we're doing lecture instead of lab, but I'm following the rules. So any questions about no food or drink? All right, speaking of which, a lot of these experiments we do have a lot of waiting. Like you'll start the experiment, then you have to check data every 5 minutes, in which case you can walk out there and eat and drink all you want while you're waiting. Wear proper lab attire. This is not a big deal in the wintertime. Usually people don't have problems with this, which is why I haven't warned you about this. But technically you need to wear long pants and closed-toed shoes. It's cold. It's really cold today, so I think everyone's doing that. But once it starts warming up, make sure you do that. For those of you who don't live on campus, I recommend keeping a pair of sweatpants and shoes in your trunk. That's what I did. Because even though I was a biology major, I had multiple labs a day or a week. Sometimes I would forget. And then I just run it out of my car, put my stuff on, and we'd be good to go. So yes, closed-toed shoes, long pants. Also, nothing excessively loose. Common sense. Any questions about attire? All right, no fooling around in the lab. I've never had a problem with this. I've been doing this for almost a decade. Everybody seems to be pretty mature, so yeah, just be mature. Exercise extreme caution with open flames. As of now, we don't have any plans to use open flames in any of our experiments, but if for some reason that changes, be careful with it. Here's a big one. Report any broken items to your instructor immediately. It's not a big deal. Like, you're not gonna get in trouble if you broke something. So if you drop something and break it, let us know right away so we can take care of it. Do not clean it up yourself. For legal reasons, you know, common sense will just tell you, oh, I dropped the test tube. There's 2 big pieces. Let me just throw it away. Don't do it. Let us do it. We don't want you to hurt yourself. Any questions about that? All right, this one also depends on the experiment we're doing, but keep all unnecessary items out of the way. So in this case, you're okay today because all the data collection will be up here. We're not doing anything dangerous. But, you know, if you're working with chemicals, like in the lab, you wouldn't want to have like her computer and then like test tubes right here, right? You wouldn't want to do that. Common sense stuff. Any questions about that? Here's another big one. Report all accidents and injuries to us without delay. This is important, even if it's a small nick. Like, you might just get a little cut. Like, oh, that's no big deal. Who cares? Go ahead and report it, because that small cut maybe get infected because of some nasty bacteria that was in here, and then you may end up losing your hand. And since you didn't report it, you know, WVSU is not held responsible. But if it's our fault, we should probably, you know, pay for your new fake hand or your amputation, whatever it may be, right? So let's document all your injuries. Any questions about that? All right, dispose of hazardous materials. The stuff we're just working with is not that hazardous. Whether it's hazardous or not, we will tell you exactly how to dispose of things. Throw it in the trash or leave it there. We'll take care of it. Whatever the case may be, we'll do it on a case-by-case basis. Any questions about that? All right, familiarize yourself with the location of the emergency eye wash station. That's back there. That green thing with the bottle, that bottle is your emergency eye wash. So you just, you know, if you get anything in your eye, go ahead and wash it out immediately. Any questions about that? All right, now the procedures for shelter in place. How many of you, this is your first semester here? Oh, good. So you've hopefully been slightly familiarized with shelter in place. So when the alarm goes off, this hasn't happened in years. One time it happened, it was real. Other times it's been, it's real. But if it does, regardless, we're going to go to the bottom of this building in the Hamblin Auditorium. Do you guys know where that is? It doesn't matter. You can just follow me. So we want to do that. Don't try to leave because it might not be a drill. So there may be a chemical spill over there. It may be wafting its way over here, maybe a deadly poison. And if you leave the building, you might die, right? So we'll all go to the basement and die together. It's easier to count the bodies when we're all in one place. That's sort of true, but also we also do have something in place to like seal the room off, so technically we might be safe. Any questions about shelter in place? All right, be considerate of others. Yeah, clean up after yourself is basically what that's saying. Any questions about that? All right, if you have questions about safety, because it's very important, ask me. If you don't feel comfortable asking me, ask him. If you don't feel comfortable asking either one of us, you know, get the information from this syllabus and contact those people. I'm telling you, if you think I'm doing something unsafe, I'm enough for you to tell me. But if not, just don't hesitate to rat me out. Safety is very important. And again, please tell me first. I prefer to just fix the mistake, but either way, make sure if you see something unsafe, you say something. Any questions about that? And then finally, even though this is a little bit less about safety, but slightly, be punctual. So again, if you're late, you can't come in. Because at the beginning of these labs, when we do the pre-lab lecture, if there is something slightly unsafe, I'm going to tell you about it in the pre-lab lecture. So then if you come in and you miss that, then you are a safety risk, right? Because you haven't heard the safety things I wanted to tell you for that lab. Any questions about that? Moving right along, graphing. You've already read this, so there's not much I can say. Plus, you're going to do graphs all throughout the semester. I'll just say this. What should I say? All right, the big thing about graphing is, I will say, when someone sees your graph, you should have enough information on the graph itself where it makes sense by itself. So today, when you make a graph, you should be able to show it to somebody without explaining what you did in lab, without them reading the lab experiment or the worksheet. They should read it and know exactly what it means. Does that make sense? There should be enough data where it can stand by itself and make sense. If you keep that in mind, then you should be good. Another thing I'll say that I don't even think is written there, your graphs are supposed to tell a story, right? They're supposed to tell the story of your data. So let's say you're doing a graph, a bar graph, right? You don't want something like that, right? Take the graph space, right? You're trying to tell a story. Like set your numbers, whatever they may be, as such a way where you're going to have big graphs and they take up a bunch of space. Does that make sense? Also, like, and again, we'll cross this bridge when we get there. But when you're setting your numbers to make your bars, you don't want to have it to where, you know, there's barely any difference when you look at it. Like, oh yeah, this looks slightly different, but mostly the same, right? If that's your lowest number and that's your highest number, set your numbers accordingly so then you have big differences between your bars, for example. Does that make sense? Again, your graphs are supposed to tell a story. Now, usually you're not going to lose points for that. Usually but if you do make a graph that could be better, I'll just tell you, hey, it can be better this way. And usually you won't lose points for that. What you will usually lose points for, and this is written here, but I'll reiterate, make sure you have a title and make sure it describes the data. So for example, today's title, you will lose points if you put lab 1. It doesn't describe the data, right? Describe the data for your title. Make sure you label your axes, right? So in today, well, I'll talk about that when we talk about today's graph. So yeah, I'll leave it at that for now.
So the title of today's lab would be hypothesis.
We'll cross that bridge when we get there. I'm glad you're asking though. So once we start talking about the data that's in the graph, hopefully you'll be able to answer your own question. Because remember, it needs to describe the data in the graph. So hypothesis testing, also not a good title. That doesn't describe the data. It describes what we did, doesn't describe the data. All right, so any questions about graphing? Again, read it, be familiar with it. Most of the semester you can do graphs by hand or using a program. For the lab report, that's the one time I will require you to make the graph using a program. Whichever program you want, but you can't do it by hand. So I recommend at least trying to get familiar between now and then with doing it electronically, but it's up to you. Hypothesis testing. This is so good. We've already talked about this today, right? So I'm going to skip a lot of this. We know the first step is the observation. Observation leads to a question. Then you come up with some hypothetical question, a hypothesis. It's a tentative answer to that question that you can test. Then you do predictions. In this lab, we're going to skip the prediction, but we'll worry about that later in the semester. But again, like we talked about earlier today, a prediction is an if-then statement that kind of describes how you're going to test your hypothesis. Also, as a reminder, predictions are an if-then statement, not hypotheses. So when you write your hypotheses, you don't need to write if-then. And again, like I said earlier today in lecture, for your hypothesis, you shouldn't end it with a question mark, because it's a tentative answer, it's not a question. So you will lose points if you have a question as a hypothesis. Experiment design, again, we talked about that today. We're going to go through it all throughout the semester, so I'm just going to leave it. You've already read it. Data collection we talked about, data organization, so tables and graphs, you're going to have a lot of that in the semester. Data analysis, in a perfect world, we would be doing statistics on your data. But this is a 100 level class. You are not biology major, so we will not be doing statistics. But do keep that in mind. So when the questions ask you, you'll get a lot of questions like, hey, can these results be applied to that? And usually your answer should be no, because to keep it simple, amongst other reasons, you could say we just don't have enough data, therefore it is statistically insignificant. We can't apply it to anything else. Presentation results, again, lab reports, we'll talk about that later. Now, let's jump into pre-lab questions. You've already done it, so I'm not giving away any answers. What are graphs used for? Anybody want to tell me? Do you guys remember what the introduction says? What graphs are used for? I don't even remember verbatim. Every time I grade it, I have to go remind myself what it says. I think it's to visualize, compare two variables and to visualize data. Something like that, right? There you go. Also, it's a good time to remind you, and some of you already got this feedback. When you answer these questions, make sure your answers come from the pre-lab introduction, because it kind of serves proof that you read the introduction. So you might have a correct answer, like, oh, what you wrote is correct, but it's not what the pre-lab introduction said, so you would lose points. No one lost points this week for that. I just reminded you in your comments. Make sure your answer comes from the pre-lab introduction. All right, I'm not going to read all this. You all read it, but we had a bunch of plants. We grew them. We measured how tall they were at the end. Therefore, what kind of graph should we use? You guys have already answered it, so you know the correct answer. For those of you who, well, no, you all know the correct answer. Even those who got it wrong, know the correct answer. So which graph would we use when we grew a bunch of plants and measured them once at the end?
Bar graph.
Bar graph, right? Because what we have is distinct data. This plant grew this much, this plant grew that much, this plant grew that much. Now, had we done this experiment and each plant, we measured them once a week for like 10 weeks or whatever, then you could have a line graph, one line for each plant, right? It started at this height, then it went to this height, then it went to this height, so on and so forth. Make sense? So again, bar graphs, individual data, right? Individual categories of data. Line graph are for continuous data. Really quickly, in that experiment, again, we already talked about this today, so I'll just say it very quickly. In that hypothetical experiment, we were growing plants in different colors of light to see if light affects the plant growth. So what would be the independent variable in that situation? Would it be the color of the light or the height of the plant?
Color of light.
Color of the light, right? Independent variable, that's what we are changing, right? The height of the plant, we're saying is dependent, or hypothesizing is dependent on the color of light. So the height would be dependent, and the color of light would be the independent. What's the key element of an experimental design? Really, there's one word that can answer this. Does anybody remember what it is?
Reproducibility.
Reproducibility, that's basically it, yep. Of course, there's a bunch of other things, but according to the pre-lab introduction, that's the number one thing of reproducibility. Any questions so far? I will bring this up. Assume you're given a set of plants, blah, blah, blah. You guys have already answered this. When you're asking a question for an experiment, it needs to be specific. Think about that because you'll get questions like this throughout the semester. So next time it asks you to write a question, think, I need to write a question that I can come up like very direct, specific question that I can give a very direct, specific hypothesis for, and then test it. Does that make sense? Those of you who didn't write one perfectly, I already left you feedback so you know how you can improve it. If I remember correctly, I don't think unless it was really bad, I don't think anyone lost points for that. I just used it as a learning moment and said, hey, this is how it can be improved. Same here, when you write your hypotheses, make sure they actually directly address your question. So for example, you wouldn't say like, do plants, what kind of, if you did it wrong, I already left examples. I already left you feedback so you know how you messed up. But yeah, make sure your hypotheses directly answer your question. And so far, no one in this class has done this, but in my other online 108 class, and maybe other 101 class online, you also want to make sure in your hypothesis that you stick directly to the question. Don't add extra information because technically if it's your hypothesis, then you have to test it. For example, in my 108 class, their first lab, they do goldfish lab. So they're putting goldfish in different temperatures of water and measuring their breath rate. So one of the question is, whether as the water temperature increases, whether breath rate increase, decrease, or stay the same. That should be the only three answers. Then some of them will go on and say, I think it'll increase because the increased temperature will stress them out. Now, once you said that as your hypothesis, now you have to test the stress part too. So you can't just count the number of breaths, which is what the experiment does. In that case, you would also have to figure out some way to determine if they're stressed or not because you wrote it in your hypothesis. So make sure when you write your hypotheses, it's only what you're going to test. Does that make sense? Now, there will be some questions in some of these later labs where it says, what's your hypothesis and why do you believe this to be true? In that case, you might say, well, I think the breath rate will increase as temperature increases because of stress. So if it asks you for it, then you can give an explanation. Otherwise, stick strictly to the hypothesis. Any questions about that? All right, what are some of the variables? You read that. We're going to go through all that this semester, so I'm not going to spend any time on that. Last question, the pre-lab. Some of these have it, some of these don't. Just put yourself in my shoes when I'm grading. I just want proof that you've read the entire lab. Meaning, read the whole lab. I know the pre-lab ends there, but I want you to be prepared when you come to lab. This one's really easy and not dangerous, so this one's a little bit less important. But in the future, make sure you read the entire lab so you know what you're getting into before you get here. Especially, like I said earlier, a lot of times if you're just so focused on the directions where you're doing step 1 and step 2 and write this down and calculate this, you're going to miss the big picture, right? You'll miss the forest for the trees. If you're so focused on the little details that you don't know what you're doing, it's useless. And that used to happen to me as a young undergrad student because nobody told me that. And I was just so focused on getting a good grade and making sure I followed the steps that I screwed it up. Well, I didn't screw it up, but I didn't learn as much as I could have. Any questions about the pre-lab? We're now done. We can now finally jump into the lab. And we're still recording. That's good. All right, so let's talk about this hypothesis testing. So I know I said you're supposed to read the lab and familiarize yourself before you come to lab. God bless you. But in this case, we're gonna pretend like you haven't read the lab. So here we go. We're starting it. Make an observation. What we're gonna do is I want you to all stand up and hold your hands out. And just everybody observe each other. Everybody look at each other and look what everybody's doing. You know, observe. And I know you've already read, so you know what you're supposed to be looking at. But pretend like you don't know. Just look at each other, make your observations. Try not to touch each other. All right, that's it. You can sit down now. So those were our observations. Based on these observations that you guys just made, can you give me some questions? And if you already know what the question is that we're going for, so don't say that one. Let's think of some other ones. There's some questions that you could ask based on what we just observed. Some questions that we could test in an experiment. Like if we wanted to do an experiment based on what we just observed, what are some questions we could ask?
Is everybody's arms the same length?
Yeah, we could do that. That would be a very easy one, right? And is everyone's arms the same length? Yep. What else? What about an if-this correlation, maybe? I don't know. Like I could think of one, because everybody was kind of doing this, so I could ask, is there a correlation between how tall someone is and how long their wingspan is, right? Right? What are some other questions? Anybody else? I mean, you guys observe each other. It could be anything. Is there a correlation between hair length and eye color? I would say not, but you guys all looked at each other. You saw it, right? So that could be a question. We could definitely answer that question and by doing an experiment. All right. So anyway, we've asked ourselves some questions, and that's what you would write here. So if you don't have to do it now, but before you turn it in, think of a question that you could ask based on the observations. Maybe it would be best if you try to pick one that we didn't use as an example just now. But think of something, try to come up with something unique that we didn't talk about where you looked at each other and it's like, what's a question that I can test? And then write a question about that hypothesis, or about a hypothesis about that question. So using my example, and don't use my example, question, is there a correlation between height and wingspan? Hypothesis, to keep it very simple, yes there is, or no there's not. Of course you could get more specific and say, yes, the taller they are, the wider their wingspan, which I would think, but you don't have to get that specific. Technically, you could say, yes, there's a correlation. That could mean there's a negative correlation, meaning the shorter you are, the wider your wingspan, right? I wouldn't think that's true, but that's still a valid hypothesis that you could test. So yeah, make sure you do those before you turn them in. All right, now that you have your question, the hypothesis, here's the actual question that we're going to be answering. As you already know, because you've read this. The question we are answering in this lab is there a correlation between height and finger span? So write at least one hypothesis right there before we move on. Go ahead and do that. Go ahead and formulate your hypotheses. Also, I'll let you know why you're doing that. In the future, a lot of your pre-labs will direct you to keep going into the lab and answer the hypothesis questions, which makes sense, right? You should formulate your hypothesis before you do the experiment. So, again, the question is there a correlation between height and finger span? And if you really, really simplify it, there's only two possible hypotheses. I mean, there's more if you get complicated. But what are the two basic hypotheses to that question? Is there a correlation between height and finger span? What are the two basic ones? Don't overthink it, because if you overthink it, there's a lot of possibilities. If you keep it very simple, there's only two possibilities. It's either this or that. Is there a correlation between height and finger span? That's one of them. He shook his head. I'm assuming he's saying the hypothesis is no, there's not a correlation. So what's the other possible hypothesis? You guys are either overthinking it or you're shy.
Definitely.
Or you're dazed out. Yes, right? So your answers are either yes or no if you want to keep it simple. Yes, there's a correlation. No, there's not a correlation. So you write down what your hypothesis is. And if you want to get specific and say, yes, I think the taller you are, the wider your finger span is, or whatever it may be, then go ahead and do that, but you don't have to. Then, and again, this is the first lab, so we're just kind of easing into things. I'm not requiring anybody to write a prediction, but you can do, if you want for this, you can do it for extra credit. And remember, a prediction is an if-then statement that's explaining how you're going to test your hypothesis. Yeah, so let's leave it at that. All right, now we need to devise an experimental design. So let's just skip ahead here. Skip ahead to this. So let's devise our experimental design. If we're trying to figure out if there's a correlation between height and finger span, what is the data that we need to collect? Don't overthink it, it's very simple. And you probably, if you did the right thing, you already read ahead and you already know the answer. What data do we need to collect? What measurements do we need to take to figure out if there's a correlation between height and finger span?
Height and finger span.
Yeah, you gotta measure the height and finger span, right? So let's talk about it. Here's how it's gonna work. Ugh. I am going to stand right here with this. These are meter sticks. We don't need to do it yet, it's all right. And I'm going to do this, I'm gonna hold this here, and you're gonna stand up. Actually, maybe you can do it, Sean. Can you stand up here? As if I'm taking you right. Yep, you're gonna do that, and then I'm gonna tell you how tall you are, right? So what are some things to consider? Here you go, next. What are some things we should consider if we're doing a good experiment design? Not the reproducibility part, but the whole variable parts. Think about the variables. What are some things we need to take into account for? And then
shoes.
shoes, right? So everybody take your shoes off. No, I'm just kidding. Don't do that. But if you were to write a lab report about this, at the end of your lab report, you'd say, here's our results, but, and you would talk about the flaws in your experiment, which is one of the questions in this lab worksheet. One of the flaws in the experiment is you guys all have different shoes on. So that is a flaw, right? We're all not barefooted. What are some other things to consider when we're doing that?
People's hair.
Hair, yep. He brought his clippers. We can all shave our heads before we do this. Just kidding again. But yeah, that is also something to consider. What else is some things to consider?
People put their feet.
What's that?
Where they put their feet.
Yeah, I didn't even think about that. But yeah, where you put your feet. Matter of fact, that is something we can control. So put your feet together like this. At least your heels together. I don't care what you do with your toes. You probably can't see me. Make sure your heels are together. What are some other things to consider?
It'll be wet.
Your head.
Huh?
The way your head is.
Yeah, head. So I guess just try to keep it straight. I don't know, straight, I guess. How do you define straight? Don't try to look up. Don't try to look down. Keep your head straight. Good. Everybody knows that. So try to do that. What else? Try to stand up straight. How about that?
Yeah.
Everybody has different variations of slouching. So those, now we know at least what we need to do. Well, there's one more thing that we need to do that we need to agree upon before we take measurements. Does anybody know what it is? I just said I'm measuring you, but I didn't say necessarily.
The unit.
Yes, the unit. Thank you. We all have to agree on the same unit. Of course, with me giving you the numbers, that's kind of agreed upon. But yeah, we all have to agree because if he says he's 6'2", and she says I'm 168 centimeters. That's not going to work for us, right? We all need to agree to be on the same page. And this is science, so we're going to use metric. I'm going to tell you how tall you are in centimeters. Now, there's one more flaw. At least there's a lot, but there's at least one more flaw that I'm thinking of. Because again, there's a question later that says, "Hey, what are some of the flaws in this experiment?" So again, you're gonna stand here, and I'm gonna look at you. I'm gonna look at it. And I'm gonna tell you how tall you are. So what's at least one flaw? I'm thinking one big flaw in that.
The position where you got us standing straight too, right?
Maybe that. To me, the big thing is I'm eyeballing it. Right? Have you ever gone to the doctors and you stand there and they put that thing down? That's very precise. I'm just eyeballing it.
Oh,
So there are flaws in this experiment. So keep that in mind as you do the experiment. And I'm sort of doing that on purpose. One, because it's the first experiment of the week of the semester, and we want to move it along. And two, I do sometimes want there to be flaws, so you can think about the flaws and think about how we can improve the experimental design. So that's it for height. What about finger span? What if I just said, all right, we know how tall you are, and I go measure your finger span. Is that good? Can I just cut you loose to do that, or should we consider some things and agree upon some things? What are some things we should agree upon?
what hand to measure?
Good. What hand to measure? I'm not sure it makes a difference. I really don't know. I'm not a anatomist or whatever. But yeah, so let's just agree to use your, let me think. Let's measure your non-dominant hand. That way you can use the ruler with your dominant hand. So if you're right-handed, measure your left hand. If you're left-handed, measure your right hand. Good. What else should we consider?
Whether you measure the hand vertical or horizontal.
Good, good. So again, that's very good because yeah, if I say measure your hand, and somebody like measures from here to here, and if someone else measures from here to here, that's not going to work. So yes, remember specifically we're talking about finger span, not hand size necessarily. So we're going to go horizontal. What are some other things to consider that we all need to agree upon before I turn you loose to do this?
We hold our hand like relaxed or.
Yes, very good. So let's agree to stretch it out as far as you can without physically pulling them apart. How about that? Sound good? Of course, that's going to throw some flaws into our experiment because some people are more flexible than others. But again, that's just a flaw that you would need to consider if you were to write a lab report on it. What are some other things? There's some big ones we still haven't talked about yet.
Which fingers are you measuring?
Yes, thank you. Because if I say measure your finger span, and she's like, all right, she measures from the pinky or from the thumb to the pinky, she gets this huge number, and then you measure from like the pinky to here, you get a much smaller number, right? That's not going to work. So let's just say these, your peace fingers or your middle finger in other countries, right? So these two fingers. We're getting there. We've almost got everything we need. What are some other things? A couple more things to consider. If we're measuring the finger span of these two fingers on your non-dominant hand, and you're spreading them out as far as you can without physically spreading them out. There's a couple more things to consider. What are
Are
they?
you talking about the measurement itself, like whatever you're gonna use to measure, like a ruler?
I didn't even say that. Good point. I didn't even think about that, but yes. So let's just all agree to use these rulers, So if you have like an app on your phone where you can take a picture and measure it, don't do that. We're all going to use the same devices, which are rulers. What else?
Where we start measuring or we finish.
Yeah, where do we start measuring? Where do we finish? For example, again, I'm just using you two as an example. So if she measures from outside to outside, and he measures from inside to inside, we're going to have different results. So let's agree to measure from inside to inside. And unless I'm forgetting something, which I probably am, there's at least one more big thing to consider before I turn you guys loose. When you're measuring your non-dominant hand, these two fingers stretch out as far as you can from inside to inside. One more thing to consider. Think about, picture yourself taking that measurement. Picture someone else taking the measurement.
Like where? Like in the middle?
Yes, where? Not just outside to outside, but where on the finger, right? Some people might go, tip to tip. Someone else might do finger crotch, whatever the proper term is for that, I don't know. So let's just agree, just for the sake of being on the same page and because it's easy, let's just do that first knuckle. That line up there below your fingernails? Let's go from inside to inside from that first knuckle. Does that make sense? Okay. Now, before we get started, and then this will be the easy part. Look how this is going to happen is you are going to measure, or I'm going to measure your height. I'm going to tell you how tall you are. Excuse me. Then you're going to use these rulers to measure your finger span, and then you're going to write your information on this board in the correct spot. So for example, if I tell you you are 168 centimeters, you're going to come under this height category, this tall category, right? Because that falls between this range. You write how tall you are, your height, and your finger span. That make sense? That's all you're going to do. Find your correct category, write how tall you are, write your finger span, and then once everyone's data is up there, we'll put the averages. Pretty simple, right? There's a spot on your worksheet that says individual measurements, which is what this is. I don't care if you write that or not. What you need is the average. Now, if you want to do some extra credit, and I'll talk about that later, then you will need all this individual data. But all you really need is the averages. So when you're doing your lab, if you want to, you can leave this part blank, because what you need is the average. So let's do one person first as an example, and then everybody else will do it. So I just want you guys to see how it's going to work. Do I have a volunteer? All right. Remind me somewhere on your lab worksheet that you volunteered to do this. You'll get a slight amount of extra credit. 1 point or something. Nothing to get too excited about. Okay. Go ahead. All right. I'm saying you are 168 centimeters. So now take that ruler, measure your finger span, please.
Y'all said the non-dominant hand.
Yep, non-dominant hand from inside to inside, first knuckle. And now obviously we want to make sure we're doing centimeters.
So maybe, I guess it's a little bit, what's it, 3.75?
Let's see. Let's see. I'm glad you asked. Those are the inches, right?
Oh, sorry.
That's all right. Yeah, we're gonna pull it up. So remember doing knuckle to knuckle. There you go. And then make sure you're always at the zero on that hand. Scoot that one away a little bit. There you go. call that 6.5. So now, under your category, let's see, wait. Make sure that, that's all right. This is why I'm having somebody do it first. Is a good, so you're in this category, 168. And what did we say it was? Does anybody remember?
6.5.
There you go, 6.5. I figured you guys knew. Okay, it's a 6.5. That's another thing we didn't consider. Let's just go ahead and consider that we're going to do one decimal place for the width. Technically, if we're doing this correctly, we would also do a decimal place for the height. So technically, I'm saying she's 168.0. I'm going to tell you now, for all of you, I would just say 0.0. So if we were doing this really correctly, we would have the same number of decimal places, the same significant digits. But for this 100 level class, we don't need to worry about it. And that's it. Obviously, if you need to use a different marker, it's hard to read, then that's fine. For the height, again, because I'm telling you, I'm not going to give you the decimal to make things easier. You can leave the decimal place off. And that's it. Let's do some measurements. You guys, I don't care if you get your height or your finger span first, but you guys come up here when you're ready to get measured and grab yourself a ruler when you're ready to measure your finger span. Yeah, I'm gonna say 166. We'll go with 184. Very unscientific. He even has a hat on. You don't need to take it off. Again, things to consider. 177. Say 188. Another flaw in this design is, well, we already kind of talked about it, 191. Like I said, I'm eyeballing this. So the taller these people are, the more accurate I probably am, right? Because that's more of a level eyeball. So when you're shorter, I'm kind of looking down. 176. One 87, 81, 181. I was way off there. 183.
Centimeters.
175. 160. 186. One. 183. There go with that. No, I'm sorry, 193. Another thing, of course, you guys wouldn't know this either. I'm supposed to be wearing glasses, and I'm not. 185. Everybody measured? Nice. So some things to consider when you guys make a graph. There is nobody in this class in the very short category, so you don't need to make a bar for it and leave it at 0. There is no data for that. You can pretend it doesn't exist. Likewise, in your table, you can leave it blank. Or if you want to remind me that it's supposed to be blank, maybe put NA or something like that. But whatever you want to do, or whatever you do, don't put zeros here, because 0 indicates that you took a measurement and somebody was 0 centimeters tall with 0 centimeters finger span, right? So that's incorrect. So again, you can ignore very short and short when filling out your table and your graph. As far as we're concerned, those categories don't exist. Another thing I want to point out is the reason we're doing it in the categories is because I'm trying to simplify this because it's the first lab. So now that you know what category you're in, I don't care about how tall you are specifically. Otherwise, we could do a scatter plot graph and have everybody's exact measurements, one dot for each person on the graph, which would be harder, and we would do something like that later in the semester. But now you're either medium, tall, very tall, or extra tall. So when you make your graph, there's gonna be 1, 2, 3, 4, 4 bars. So, for extra credit while I'm talking, does anybody know how to do averages? Do you want to do that while I keep talking? Anybody?
Just add them all up and divide it by.
Exactly. So add those up, divided by 2. Add that up, divided by 2. Add those up, divided by 3, so on and so forth. If you guys want to do that while I'm yapping away, who volunteered to do that? All right, yeah. You do that. Write the results on the table if you don't mind, and remind me somewhere on your lab worksheet that I'm giving you extra credit.
So add them and then divide it by 2? Or how many?
However many, yeah. So add these up, divide by 2. Those would be divided by 3. 1, 2, 3, 4, 5, 6. That would be divided by 6. Those would be divided by 3. So let's look at this while somebody's doing the averages. All right. So far, that all looks good. Okay. This is also something very important for you guys. A little bit relatively important. Because none of you are biology majors, so you're probably not going to be doing scientific studies in your real life. But in your real life, somebody might present you with scientific studies. Like, hey, I want you to buy these essential oils. Here's a study that we did. And then you should look at the data instead of trusting people. Look at these studies. Look at the data. And you should be looking for red flags. I think I see, I don't know, some of these things stick out. 5.5 seems a little bit low, but not necessarily because the other two data were 6. But then look, here the highest data we have in the next height category is 7. It's a full centimeter bigger than this. 5, 6.4, 6. Actually, you guys are pretty good. I was kind of hoping there'd be more mistakes so we could have a good learning moment and say, hey, look, that's obviously something's wrong here. But all of that might actually be accurate. All right, let's talk about the graph. Let's see. So again, well, actually, not again. Let's talk about this very quickly while somebody's doing these averages. Somebody is doing the averages, right?
Yes.
All right. Remember what? Yeah. Anyway, for your graph, like we already said, we need 1, 2, 3, 4 bars, right? And I'm going to abbreviate here, but you should write out the whole thing on your paper. But we'll have a bar for medium, a bar for tall, a bar for very tall, and a bar for extra tall. Make sense? That's your x-axis because those are the categories. We have those 4 categories of heights. So, what should we label this? We've already labeled it. You know what? I'll just leave it at that. One mistake I see people make, and I kind of like the mistake, is they're thinking the right way. It's just in this particular instance, it's messing them up. So a lot of times people put height and in parentheses centimeters, which normally would be correct. But we're not really, once we've categorized you as medium tall, very tall, whatever, you're no longer 166 or 182. You're just whatever your category is. So for this particular example, you don't need to write height parentheses centimeters because it's no longer in centimeters. You're just categorized. Does that make sense? All right, so that's your x-axis. What are we going to put on the y-axis? What goes like, so for the medium, what goes here?
Length between the fingers.
Good, yes, the length between the fingers, right? The finger span, the FS that I abbreviated. So that's going to go there. And remember, we want our graphs to tell a story. So we don't necessarily have to start at 0. We want to look at our biggest numbers and our smallest numbers. So, I mean, we don't have the averages yet, but looking at this, let's look at the heights. Yeah, what is our smallest? Well, no, let's not look at the heights. Good grief, I just asked him and he just answered it. Finger spans. Looking at all these numbers, even though we don't have averages yet, what's the smallest number for finger span that you see?
5.
Yep, me too. So your graph, again, doesn't have to start at 0. You also don't want to start it at 5 because then it wouldn't have a bar, but you would have it somewhere close to 5, right? Maybe, I don't know, let's just say close to 5, right? I'm going to write 5 near there. What's our biggest number? 7. Good. So somewhere near the top, you would want it to be 7. That makes sense? That way you're having the big differences between your bars. Again, it doesn't have to be starting exactly at 5 or ending exactly at 7. That's what you're kind of shooting for. You want to use up a lot of graph space. And when you do it, use your graph paper. You're going to want to use as much graph paper as you can, assuming you use this graph paper and don't do it electronically. And again, try to pick your numbers to where you have big bars and take up as much graph space as possible. Does that make sense? All right. And then going back to what I said earlier that he answered, like I said, what's going to go on here? He said finger span. So you do need to label. You already labeled your x-axis because you've got these categories. So I guess you could write height. Technically, height categories would be better, but that's kind of implied because medium, tall, very tall, blah, blah, blah. And you don't need to write centimeters in this case because we're no longer in centimeters. We're just categories. So here, like he said, and I'm going to abbreviate just because it's a whiteboard, but you would fully write out finger span. And then what should I put in parentheses right there next to finger span?
Centimeters.
Good. CM, centimeters. Always use your units. And that's it. So what you'll need to do, now that we're done with the experiment, is fill out your papers, do your graphs, come to me for help because you might need help. Like, all right, I did the graph. How do I get it into the worksheet? There's instructions on how to do that, but also I'm here and I can help you. And remember, you need to upload this before you leave today. So even if it doesn't matter if it's wrong, because it may have, I was rushed, I missed this. That's okay. I'll let you know you missed it, and then you can re-upload it sometime any day before Friday, because it's past due on Friday. So that's it. You guys are cut loose to do your work. Yeah, and I'm here to help. He's here to help. Since this portion is now online, I'm going to be here online to help you. I'm going to look at some of these questions and see if you might need help with them. Yeah, insert a graph. Question 11 asks, what was your hypothesis and was it correct? That's going to be a very common theme throughout the semester. I know it seems redundant, but yes, I need you to repeat yourself. Yes, I can look back and see what your hypothesis is. Yes, I can compare it to your data. And yes, I can see if your hypothesis was correct or not. But I don't care if it was correct or not. What I care is that you can analyze data. So you need to repeat your hypothesis and tell me if it was correct or not for question 11. Question 12, we've already talked about. What are some of the flaws in the experiment? Right, we talked about it. So you're going to write those down, as many as you can remember. The fact that I'm eyeballing, the fact that people were wearing shoes, different hair. What's some other stuff we didn't say? Your height changes throughout the day. I don't know if you knew that. Generally, you get shorter throughout the day as your vertebrae compress. Of course, when I'm taking these kind of measurements, that's not enough big enough difference to matter. Question 13. Let's answer this together, then you can write it down. Can these conclusions, whatever you conclude once you're done, and I'm going to need somebody to write those averages, or you guys can calculate them on your own. Anyway, can these conclusions be applied to the entire human population? So let's say, well, it doesn't matter. Either there is a correlation or there's not. So whatever it is that we decide, can we apply these conclusions to the entire human population? What do you guys think? And I kind of hinted at this in the pre-lab lecture.
I have one question. If we're doing it by paper, you want to show us how to insert it in here? Or?
Yeah, once you're done making it, I'll show you how to do it, yeah. So does anybody have to answer that question? For question 13, when you come up with a conclusion, can that be applied to the entire human population?
Yes.
What's your reasoning?
Because we're all humans, we should all have hands.
That's true, but the correct answer, I like your good thought process though. So obviously now the answer is a yes or no answer. So the answer is no, it can't be applied to the entire human population. Anybody tell me why? There's two basic reasons. And we've touched on them today. Why can't we apply these findings to the entire human population?
Not everybody has hands.
Well, that too. I didn't consider that. Yes, that too.
And there's no way to measure everybody on the planet.
That's kind of what I was getting at, yes. Or, as I said earlier,
Aesthetic growing,
what is it?
the population aesthetic growing.
Yeah, our sample size isn't big enough. So I like what she was getting at, where she's like, we can't measure the entire human population. But that's where statistics comes in. If you have enough of a big enough sample size and have enough data, then eventually you can apply that to the entire human population. And the more data you have, the more statistically significant it is. So the short answer is no, we cannot apply it to the entire population because our sample size is too small. Not to mention all the flaws in the design of the experiment. The way I measured the height, the way you guys measured your finger span, the fact that, well, yeah, we can just leave it mostly at that, you know. So yeah, that's the answer to question 13, or that should tell you what you need to write on your own for question 13. Question 14, regarding someone's finger span, what additional questions could you answer if you worked with a variable other than height? So for example, is there a correlation between weight and finger span? So question 14 is asking you to come up with another question that we could answer in an experiment that has to do with finger span. So not height and finger span, because that's what we just did. Not weight and finger span, because that was the example. But something else, just come up with anything else that we could test in an experiment. Is there a correlation between length and finger span? And that's really it as far as the questions. Yeah, 15 questions. So again, I'm here to help. Once you've uploaded your lab, you're free to go. And that's it. I will do my best to get it graded as early as I can so you can make corrections before the past due date of Friday. Does anybody want to put the averages on the board?
Oh, yeah.
I only ask for those students who were not able to be here. It is being recorded, so hopefully they'll be able to see it. Which brings up another good point. So this is going to be the way a lot of these experiments are. We're going to collect data as a class. One person's going to do some math. But I also have old dad brain. So if I'm doing an experiment, if I'm grading one of your papers, like using this as an example, and I say, all right, your average is wrong, and I deduct a point, then you could just reply back like, yeah, but that wasn't my calculations. We did it as a class. So feel free to correct me. However, you know.
I have to put pressure now.
That's okay. That's all right. And actually, I kind of hope you do mess it up. Not because I wish that you mess up, but particularly, but because it would be a good learning moment. And I'm already seeing something already. No, but this is good. Before you fix it.
Don't even
No, this is good.
Don't
So look, we're looking at averages. Oh, here's another hint so you know how I grade. One thing I'm not going to do, because I don't have time for this, is calculate every single one of your, or check every single one of your calculations. Here, we had the average of 259.5. I can tell without a calculator. Don't feel bad. This is perfect. I was hoping this would happen. This is why I kept saying somebody put the averages on the board. I was hoping we could have a mistake and learn from it. How can I know that's incorrect without calculating it? That's okay. Don't feel bad. I'm glad it's an easy mistake to make, and I'm really glad you made it.
We don't have anything close to 259.
Right, yeah. So the highest number we have here is 176. You don't need to get, well, I guess you can do it. And the lowest number we have is 168. So I can tell it's outside the range. So throughout the semester, hopefully you will double check your calculations. But even if you don't get out a calculator and double check it, at least look at it, especially with averages, to make sure it falls in the range. Does that make sense? Because that's largely how my grading is going to go. I'm going to look at it, and if the average is within the range, I'm like, yeah, that's probably right. I don't have time to take out a calculator for everybody. That should piss me off. No, I'm just kidding. But good, and like I said, I'm glad you made the mistake. It's an easy mistake to make, and we can learn from that. So just keep that in mind when you guys do your own labs. And another thing, it has nothing to do with this,
I'm still getting that answer. Am I doing it wrong?
but must be. So you add
Oh.
these and then divide them by
About
3.
three. That's what it was. I was dividing by two.
Another easy mistake to make, because look, there's this big gap between them, so kind of like your eyeball kind of sees too. Let's see that. But anyway, No one's done this yet this semester, but don't use AI to answer your questions. It's something that's very obvious when people use AI. Just answer your own questions. Even if you get them wrong, there's no pressure. If you get it wrong, just fix it, get your points back. Don't use AI.
So this is pertaining to what we was talking
Oh,
about.
I'm so glad you showed me this. First of all, before you even ask, before you even answer that. So for this, you just write your answer here. I don't know what's going on there.
This is our conversation.
Oh, perfect. Never mind. Okay. Oh, yeah. Okay. So what was your question? Sorry.
So the hypothesis is what we're talking about now. So I need to come up with the finger span.
So this is the pre-lab, right?
Mhm.
Yeah, good question. So for the pre-lab, this is something about plants, right? Oh, wait, I'm sorry.
Yeah.
This is the lab itself, not the pre-lab.
This
Okay, okay. So yeah, in that case, since that is the lab, you don't need to do all that side stuff. So like you literally, you don't mind?
Yeah.
Okay, first of all, delete that. Like when you want to answer this, just go in here, type your answer.
You got this.
But, so, that being said, so then you just repeat your hypothesis like that. Yes, there was a correlation, no, there wasn't a correlation, whatever it was. Do you think it was correct or not? Yeah. And this one, I have to be
I think
honest,
it's the wording that's the problem.
I understand. Oh, wait, we still have, I'm sure you guys will catch it. And
Yeah, don't, I'm sorry.
No, don't. It's great. Like I said, I'm glad they made the mistake. But you guys might want to make